Hey everyone, this is the beginning of Unit 1B. So Unit 1 was a really long unit that I just wanted to split up a little bit. So this is the second half of Unit 1. We are starting with nomenclature. This is stuff that you all learned in Chem 1 last year. So hopefully this is just a little bit of a refresher and maybe diving a little bit deeper. So there is a video, I just really like these crash course videos. This is on the class website too, so if you want to go on your own time and watch this on the website, it should be a little bit helpful. So our question of the day is, why is it important to have a universal naming system for compounds in chemistry? So really, this is something that you just think about on your own. Make sure you're filling in your notes page as you watch this video. In order for scientists, different companies, and even industries in the world, for them to be able to exchange just different scientific information and data, it's really important that everyone's on the same page with naming compounds. So it's important to have a universal naming system so that everyone understands what the other people are talking about. So we have three different types of compounds in chemistry that we talk about. We have covalent, ionic, and we have acids. So again, all these we talked about last year in Chem 1. So as a refresher, a covalent compound is when you have two or more non-metals that are bonded together. So when we're naming these, this is when we use those prefixes. So we use a prefix, we name the actual element, and then we just drop the ending and add IDE. So an example of that would be hydrogen monoxide. Here's some important prefixes. I would just go ahead and memorize those. Those should look familiar to you. One exception for covalent compounds is just remember, if that first element, if there's only one, we don't have to say mono, only for the first one. Now, if the second element only has one, we do say mono. So just that first one, we can skip it if there's only one. So for example, CO2, even though there's only one carbon, we don't have to say monocarbon. We just say carbon dioxide. So here's some examples for you. We're doing these together in class, so I'll kind of just go through each one. I won't be able to write them down on this slideshow, so you may spell it a little differently. That's okay. So I have nitrogen and chlorine. So since I'm using prefixes, I don't need to say mononitrogen. I can just say nitrogen, pentachloride. It's penta because I have 5 chlorine. Okay, next one, CO. That would just be carbon monoxide. And last one, diphosphorus pentoxide. So we're just using those prefixes to figure out how many we have. So it should be P2O5. Okay, how do we drop the ending of an element to add IDE? So this is just something you kind of have to get used to. Every element's a little bit different. There's not just a straight out rule for this. So for example, phosphorus changes to phosphide, carbon to carbide, oxygen to oxide, nitrogen to nitride, chlorine to chloride. This is just something that as you do it a lot and you practice, you'll kind of understand it more. It just takes practice. Some other important info for covalent compounds. Covalents are a neutral molecule, meaning they do not have a charge, okay? So if you see a molecule like SO4-2, that 2 at the top means it's a charge. I also know that this compound is a polyatomic ion, and we'll talk about those a little bit later. So polyatomic ions have their own naming system. Really, if it's a polyatomic ion, it has a set name, and it will always be that name. Okay, some other important stuff. If a compound has hydrogen at the beginning and the molecule is neutral, we use the acid naming system. So HClO3, it doesn't have a charge noted, so it would be neutral. Because that H is at the beginning, that makes it an acid. So again, this is stuff from Chem 1. Hopefully this is bringing back some memories. Many covalent compounds have a nickname, so if it has a nickname, it's just better to use that name. So CH4 is methane, NH3 is ammonia, H2O2 is hydrogen peroxide. So if it's something common like that, it'll have its own little nickname. Okay, our next type of compound is ionic. So this is when you have a metal and a nonmetal. There's two types of ionic compounds. There's binary, which contain two elements. Bi means two. And there's ones that contain a polyatomic ion. So it's a metal, but it's bonded to more than one nonmetal. Remember, poly means many. So when naming ionic compounds, we use the metal ion name and the nonmetal ion name. The only thing we do is add IDE to the end of the nonmetal, which is usually the second element. You do not use prefixes for ionic compounds. Okay, nonmetal ions that aren't polyatomic all end in IDE. Even though we're still using IDE, this does not mean it's covalent because we're not using prefixes. There's a charge in every ionic compound. We don't write it. We just know that there is one because there's a metal and a nonmetal bonded together. In this case, we do the swap and drop charges to figure out the chemical formula if you're just given a name. We'll talk about that in a minute. Okay, here's some examples for you. So our first one is, aluminum chloride. So to figure out how to write out this formula, you have to go to the periodic table and find their charges. Remember, the charges are based on what group they're in on the periodic table. So aluminum would have a +3 charge. Chlorine would have a -1 charge. So when I swap and drop, what should I get? I should have AlCl3. Okay. Magnesium and iodine. If I'm just naming it, all I have to do is add IDE to the next one. So it's just magnesium iodide. And then last one, aluminum sulfide. So again, I'm taking the charges from the periodic table. Aluminum's +3, sulfur's -2. Swap and drop the charges, so it should be Al2S3. Okay, here's some other important information for ionic compounds. From our unit on bonding, which really that's from last year. A polyatomic ion is a group of atoms that function as one charged molecule. So if it's polyatomic, those atoms are usually staying together. Polyatomic naming, which we'll talk about more in a second, if it ends with ATE, we drop the ending and add IC. So chlorate is chloric. Okay, if it ends with ITE, we change the ending to OUS. So hypochlorite would be hypochlorous. And we'll talk about that in a second. Okay, so here's again how to find the charges on your periodic table. The charges are basically what group it's in. So group 1 is +1, group 2 is +2, group 3 is +3. Group 4, where carbon is, could be plus or -4, okay? Group 5 is -3, group 6 is -2, group 7 is -1. And remember that group 8, those noble gases, those are pretty much stable. They have full valence shells, so they do not have a charge. That's group 8, does not have a charge. Here's some polyatomic ion examples. I think it's a good idea to just go ahead and memorize as many polyatomic ions as you can, especially if you're taking chemistry in college. Okay, some other important information. The IUPAC, which is basically who decides how we name these things, they require that the charge on the transition metal, if it's a transition metal, it's in that middle section of the periodic table, it's indicated by the name and then a Roman numeral after the name of the metal. So that Roman numeral tells us the charge. The reason that we do this only for transition metals is because it doesn't matter what group they're in on the periodic table. The charge is kind of random. So I'll give a handout for those charges. But basically the Roman numeral is going to give us what that charge is. Okay, so here's some practice. I have Na3 PO3, excuse me. So PO3 is a polyatomic ion. So I would go look at that polyatomic ion list. Let me pull mine up on the computer. Let's see. So PO3 is phosphite. Let's see here. So I have sodium at the beginning. So all this would be is sodium phosphite. Okay. Next one, what's the name of the compound MnCl2? Mn is manganese. That is a transition metal. And then we have chlorine. So that 2 after chlorine, if they had to swap and drop the charges to get this formula, we can work backwards to figure out the charge of manganese. So manganese would have a +2 charge because that 2 is on the chlorine. So it'd be Mn, or manganese, and then in parentheses, Roman numeral 2, and then chloride. Okay, last set of compounds. We have acids. Acids are ionic compounds. There's a hydrogen with a +1 charge acting as the metal. They have their own naming system. So we name the negative ion that's bonded to the hydrogen, and then we change the ending of that ion just based on whatever the rule is. And then lastly, we add acid to the end of the name. So here is how to do that. For those negative ions, if it ends with ATE, we change it to IC. If it ends with ITE, we change it to OUS. If it ends with IDE, we add the prefix hydro, and then we add IC to the end. Okay, so let's do some examples here. I have, let's see, H2SO4. Let's see here. All right, so the negative ion would be the SO4. That 2 came from the polyatomic ion SO4. So we know that the SO4 had a -2 charge, and that is sulfate. So it ends with ATE, so we drop the ending and add IC, so it's sulfic. So we would just say sulfuric acid. The next one, we have a polyatomic ion, PO3 -3. That's phosphite. It ends with ITE, so we're changing the ending to OUS, so phosphorus or phosphorus. Now that it's an acid with the hydrogen, we would just call it phosphorus acid. Perchloric acid, perchlorate is a polyatomic ion. It's ClO4. So that comes straight from your polyatomic ion list. So it'd be HClO4. And then lastly, we have HBr. Br is bromide, right? It's bromine on the periodic table, but because it's a negative ion, we would call it bromide. So since it's ending with IDE, our rules tell us to add hydro to the beginning and change the ending to IC. So hydrobromic acid. Okay, so I'm going to let you go now. You have time to do the guided practice problems. If you have any questions or you're stuck on one, send me a screenshot and